Okay, section 8.3, number 2. So in 8.3.1, we dealt with linear equations. Today we are dealing with quadratic equations. So remember with quadratic equations, you are going to have to either factor, quadratic formula, completing the square, one of those processes, because you are going to have 3 terms for these particular problems. Most of them can be done by factoring, but if you need to use quadratic formula, you can. So rewrite the trigonometric function to represent the quadratic form. Factor, set each factor equal to 0. And then again, you're going to use your trig library in order to find the angles which satisfy this equation. All right, again, we're just going from 0 to 2 pi, so 2 pi will not be an answer. All right, on the first one, notice you have a square term and a regular sign. If you need to, you can think about this as letting x equal sine theta. So you can rewrite your problem as 2x squared minus 3x plus 1 equal to 0. And then this is an AC type question. So you can go straight to your factors if you know how to do that. If not, because it's AC, that means we are going to multiply the 2 and the 1, which equals 2. And then I'm looking for factors of 2 that add together to equal 3. So notice that 3 is a negative 3. So when I have my values, they both need to be negative. So negative 1 plus negative 2 equals negative 3. And negative 1 times negative 2 equals a positive 2. You can use the grid if you want to. In order to do our factoring, so do it the box method. You can also use the factor by grouping. I'll go through both ways. So with the box method, we had our first term in the first box, our last term in the last box, and then what we're replacing goes in the middle too. So negative 1x and negative 2x, and it doesn't matter which one you put where. Then we're looking for a GCF. So the top row, both of these have a positive 2 and an x. Because this first number here is a positive, I'm always going to take out a positive. So whatever's on the outside. And then I know that 2x times x equals, or 2x times x equals 2x squared. And x times what equals negative 1x. That would give me negative 1. Negative 1 times what equals 1. That would also be a negative 1. And then you have to just double check. Does 2x times negative 1 equal negative 2x? Yeah. So our answers are factors that are 2x minus 1 and x minus 1. If you're doing it by a factor by grouping, remember we are replacing our middle term. We're taking out that 3, and we're replacing it with the negative 1x and the negative 2x. Everything else is going to stay the same, so we're just replacing the negative 3. Then factor by grouping, you're grouping the first 2 and the last 2. The first 2 have x in common, leaves me with 2x minus 1. The second set, because I've got a negative in the middle, I do have to take out a negative, and I always have to take out at least a 1. So if they have nothing else in common, you're just going to take out 1, and in this case, negative 1, so both values change to their opposites. Make sure those parentheses are both the same. If they are, they go out front. Everything else goes in that second set of parentheses. So our everything else this time is this x and our minus 1. We're then going to take each set of parentheses, set it equal to 0. Remember, we're just doing opposites. So on this left-hand side, we're going to add 1 and divide by 2. So we have it written down as x, but remember that x was our sine value. So I'm going to be looking up, where does sine of theta equal 1/2? Or sine of theta equal to 1. So I've got a snapshot of the trig library. This happens in 3 different places. So I have 1/2 is in 2 different places, and the 1 is a quadrantal, so that means it's on one of the axes. So again, we're just putting down our radian values. So our answers will be pi over 6. We have pi over 2. And we have 5 pi over 6. If you need to, go back and look up how to solve by factoring. Now you could have taken this problem and done it by quadratic formula as well. It will work, just using your A as 2, your B as -3, and your C as 1. I don't have to see the factoring if you're doing it by quadratic formula. All right, next problem. This one we have things a little bit on both sides, so we want to make sure we set it equal to 0. Because my squared term is a negative on that right-hand side, that means I want to move it to the left to make it positive. So I'm going to have 2 cosine squared theta. Putting that first because I always want my squared term to go first. I'm going to just go ahead and write this all down. I still need to set it equal to 0, which means I need to subtract that 2 from both sides. And so we're going to have 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. Now this problem is very similar to the last one. Notice we do have a positive 3 instead of a negative 3. And everything is positive in the problem, so everything's going to be positive in our answers. Again, I'm going to let x this time equal cosine theta, so I can rewrite this in a simpler form to be able to solve. Again, you can use quadratic formula. I don't recommend completing the square, but factoring does work. Again, it's an AC type, so 2 times 1 is 2. Factors of 2 that add together to give me 3 would be 2 and 1. So I have 2x squared plus 1x plus 3x plus 1. Did that wrong, sorry. But I do want to go ahead and I want to change the order this time. So what happens if I put the 2x first and then the 1x? So what is that going to look like in my problem? So when I do my factor by grouping, I'm going to take out a 2x, and I'm left with x plus 1. Don't forget that 1 is very important. The second set, I have a 1 in common. I have to take out at least a 1. My parentheses are again the same, and I put what's left in the other set of parentheses. So what's left is what's outside of those parentheses, so my 2x plus 1. Again, we're going to take each set of parentheses, setting them equal to 0. So I have x equal to -1. The second one is going to give me my -1/2. So this time I'm going to be looking up in my chart for cosine because x was equal to cosine of theta. So I want to make sure I use the cosine part of my table. I'm looking for -1 and I'm looking for -1/2. So that's going to occur 3 different places. So my theta is going to equal 2 pi over 3 pi and 4 pi over 3. Now, is there any correct order of putting these on to an answer? Absolutely not. So you can have those in any order. Sometimes it's just easier to have it from smallest to largest. All right. Next one. This time, notice I only have 2 terms. Because I have 2 terms instead of 3, I can try to do something a little bit different. I'm still going to start with my x is equal to sine of theta. And I'm going to take out the sine values and replace them with x. So when I look at this, notice I have an x in both terms. I'm going to have to take out a GCF. Now you could do this with factoring, putting in a little plus 0 here and factoring it that way, but just as easy to just take out a GCF. So again, I'm going to let each one of these equal to 0 and solve. That right-hand side, very similar to the others, is going to give me 1/2. Your answers, remember, square root of 3 over 2, square root of 2 over 2, 1/2, 0, 1, those are the main numbers you're going to be looking at to solve the problems. So this time I'm looking for 0, I'm also looking for 1/2. It does occur in 4 different places this time. So I will have that theta is equal to 0, pi over 6, 5 pi over 6, and pi. Because those numbers are all positive, all the answers will lie in the first and second quadrants. All right, next one. This one's already done partly for you. It already has parentheses. Don't factor, don't multiply them together. You are simply going to take those parentheses and set them equal to 0. So that means I'm going to be looking up cotangent of theta is equal to 1. And I'm going to be looking up cosecant of theta is equal to negative 1/2. All right, so looking at my table, cotangent of equal to 1 is going to occur at 2 different places. So my theta is equal to pi over 4, and it's equal to 5 pi over 4. Now, look as much as you want for that cosecant. It does not exist. What happens in that particular problem? For cosecant, the reason why it doesn't work, remember that cosecant is equal to 1 over sine. So they're reciprocals of each other. So sine theta is equal to negative 2. When I put that on a chart, it's a negative value, and so it's going to be in the fourth quadrant. And if I think about sine, sine is opposite over hypotenuse. So when I put those numbers on my picture, negative 2 and 1, what do you notice about the hypotenuse? It's too small. Hypotenuse always has to be the longest leg, and because it's not the longest side of my triangle, it's not going to work. This will not exist because that 1 was too small. It's not going to work. All right, that's it for today's notes. Remember, if you have questions, please email me, and good luck. There's the assignment.